The next presentation will be made by Andrey Sechin, the scientific director of the company Racurs, who will speak about dense DSM generation module in PHOTOMOD 6.0.
Once again, hello. Last year I told you about new algorithms to be used in dense DSM generation module. So now I'm happy to report that, and that was not mentioned by the previous speaker, PHOTOMOD 6.0 has that algorithm to generate dense DSM module, which I advertised last year. This is not part of the standard DSM generation. It requires separate licensing. Of course, you can get familiar with it during the masterclass on Wednesday. I used the word terrain or relief, but in fact we're talking about a digital surface model. The word surface is key. There is some confusion in Russian. I assume there is also some confusion in other languages about the terms centuries. And try to build a model. We will have something similar to what you see in the middle picture. There will be a lot of inaccuracies, edges will be rough, but on the other hand, this digital surface model can be filtered, which is what they used to do to make orthophoto later. Yuri Reisman mentioned that PHOTOMOD filters are recommended for usage in this case, but in fact we'd better have a dense point cloud, a dense DEM, much similar to what you see on the right. This is done in a semi-manual mode. So I will share with you what we have achieved. These are the problems you come across when doing this. On one image you see one wall, on the other you see the other wall. You try to find common points, so when conventional methods are used, the building doesn't look right. So to supersede this approach, global methods, or more particular semi-global matching, came to be. But we developed our own method that shares the features of global and local matching, which we subsume under global matching, and we called it iterative demotive method. This is another picture showing the standard cross-correlation and the global or iterative deformation method that gives you more plausible picture. So what does IDM dwell upon? If we know the surface, the correct surface, and if we build orthophoto from different images over the same area, roughly speaking, these orthophoto plans will be true orthophoto and they must match. And we will adjust the surface so the three orthophotos should match. I can illustrate this point with this diagram, this drawing, if you will. So these horizontal plates display different height approximation levels. These are not planes, of course. These are more complicated objects, including various parameters. So the idea here is that oftentimes we use cluster architecture, parallel computation, and from this picture you can see that we can parallelize not only by areas when we cut the area and calculate one rectangular shape on one core. We can use parallel approximation, we can use different images, we can use pyramidal levels for that as well, and that gives some advantages, added value to our methodology. Shure or Shure software developed at University of Stuttgart was repeatedly mentioned today. We wanted to do a side-by-side comparison. So if we launch Shure on a local, quite powerful computer, then SGM was 20-30% faster than our method. And Shure is one of the fastest SGM applications. As soon as we started using two similar computers, we sped up our algorithm, outstripping Shure in speed. Semi-global matching uses bipolar geometry, and our method does not. So, if data is processed from space, that creates certain advantages, because bipolar geometry, spaceborne imagery, is quite approximated. Another advantage to our method, semi-global matching considers stereo pairs one by one and then generates one common surface model. What we do is that we process different images in parallel, even though the previous picture showed just two. As a mathematician, I like this SGM algorithm. But what you embedded in it, you cannot control. In our method, depending on whether it's a building or some construction site with cranes, we try to use image detection, identification, and based on that, use different strategies, different height approximation functions to get better results. There is a well-known international test, I'll show you later, the Munich aerial survey by DSM. So we compared our algorithm and Shure. 90% of points, the divergence was not that great, around 54%, especially in our later editions. So this is the user interface of PHOTOMOD 6.0. It's quite simplistic. On the left, we set the number of cores, then we tick distributed processing, and where we are going to create it, or delete intermediate data. And then I showed you this picture before. It's the GOI stereo pair that didn't give us very nice looking buildings with a lot of inaccuracies. Now with our approach, they're looking not so bad. This is GOI based application of our method. Now it's Tallinn, where we relied on the worldview 1, and this video will show that even one stereo pair, and we were quite surprised because we always say you should have the point on 4. So anyway, it gave you a decent picture. We don't do the correct texturing of the results obtained. We simply take an ortho photo and superimpose it or overlay it on the generated surface. And this is the final product. When we showed this to the others, it was quite appreciated. Now this is aerial photography. This is matrix of altitudes, of heights, and this is semitone image of the same area. This is low storied development area. But once again, I highlight that we do not colorize the side walls. And this is the Munich city, the testing ground for all the others. It's a benchmark. We haven't sent our results yet, but we compared ourselves to Shure. This is how the Munich city looks. Of course, they and us have defects, but all in all, the results are very close. There is one church here, I don't know if we get to see it. We display it much better than the German product. Now let's see how, as it spins. This used 80 to 60% overlap, side and forward, respectively. This is a simple example, a terrain with a lot of rocks. This is one of the earlier results we obtained. Everything was nice here from the beginning. As in semi-global matching, you don't have to use the algorithm for the developed area, but still it requires great computer power. Remember that. So with this I end my presentation. This is the model of Yekaterinburg, which was mentioned and exported in AutoCAD. PHOTOMOD generated this image in a semi-manual mode. Digital surface model was generated by PHOTOMOD, and then the buildings were overlaid by hand from conventional ground surveying. Thank you very much. Are there any questions? Yes, colleagues? Спасибо, Андрей, за вашу прекрасную презентацию. У меня есть вопрос. Хотелось бы узнать, сколько опорных точек вам необходимо для ЦМЛ на площади 100 километров. Просто любопытно узнать, чтобы получить какое-то представление. Количество опорных мы можем лишь точность выдать. По-английски говорят. The number of ground control points determines the accuracy of adjustment. and it hardly relates to digital surface model. You can generate digital surface models without ground control points, actually. Большое спасибо. Вот такой ответ мне и нужен. Спасибо. Any other questions? I have a question, actually. I have two questions, actually. Is what you presented, what camera? A3 camera. We can give it a try. In fact, our algorithm is not finished yet. We only have some... But they did try to use it on Jerusalem. Do you have some tests? A3, we did try with A3 images, didn't we? So, what results did you obtain? It wasn't Munich, of course. It was worse than Munich, but we used the version still under development. Well, I'd like to have a look. During our master class on Wednesday, we will show the survey of Lyon city. I'm quite impressed. Yeah. Thank you very much.